Hey class, welcome. As you can see, I am not there today. I am there, but I'm not there. I am working downtown. So you are in great hands with Mrs. Ehlers. What you are to do today is watch the video, take some notes, show her the notes. Once you're done, get your assignment. Now, I had some awesome fun facts for you, but this is my second take on this video, and the first one was way too long. So I have to cut those out, but I will make sure I get you some extra fun facts on Friday. Check your homework. Hopefully, Karina, should we give Karina a Wolverine clap on three? 1, 2, 3. Because I heard she read the answer keys. All right. I'm also going to not go over dividing complex numbers because I think that's going to be better done with me there on Friday. And we are going to just touch lightly on completing this square and have a very short assignment. We ready to rock and roll? Here we go. All right, so equations with pure imaginary solutions. These aren't any equations. These are actually called quadratic equations. And if I was to graph a quadratic, this was way back from when Mr. Mounts is here, he explained that a quadratic solutions are when you cross your x-axis. So for example, every quadratic usually has two answers. So there'd be an answer here and an answer there where it crossed the x-axis. It could also look like something like this. And maybe this is at -2 and at -4. Sometimes you run across quadratics where there's only one solution, and that would be where it only crossed the x-axis once. And then in the past, if you were to graph a quadratic that looked like this, you would have said, oh, it doesn't cross the x-axis. That's a no solution. Mind blown. We know complex numbers, which means now we can have an answer to that. It's called an imaginary solution because it involves some complex numbers. So yeah, there's going to be two solutions, but more than likely it's going to involve an I in it. How would that look like? If I asked you to solve this, you'd be like, oh, I know how to do this, Miss Bradford. I would subtract 64 from both sides, and then I would have x squared equals a -64. And to undo something that is squared, I take the square root of it, and then I would have x equaled, ooh, Miss Bradford, that's a negative under that radical. That is a negative under that radical, but we learned that we can just pull out that -1, and that's going to turn into an I eventually, and then radical 64. So my answer is I, and then radical 64 becomes 8, but we don't go I8. We actually say 8I, and we're going to go a step farther, is we're going to say a positive or a negative 8I. And the reason is, what's 8 times 8? 64. What's -8 times -8? Positive 64. So that's where we get the positive or negative 8I. So if we were to do that again on the second one, try to do it without me. Pause me or follow along with me. -100. So I'd have 4x squared equals -100. Divide by 4. X squared equals -25. Take the square root of -25. And I would have plus or minus 5I. Okay? I can go over those again on Friday. So completing the square. Ooh, back in the day, I used to have to write my learning targets like this. Students will be able to solve quadratic equations by using the square root property. I'm not going to get here. We're going to do this on Friday. So here's the square root property. Ooh, that looks ugly, doesn't it? Okay, let's take this back a notch. If I was to say, hey class, remember FOIL? FOIL me this, x plus 3 squared. Well, you would say that's x plus 3 times x plus 3, first, outside, inside, last. Well, this would become x squared plus 6x plus 9. And I'd be like, ooh, you're awesome. FOIL me this, x plus 6 squared. And again, you would FOIL it out and you would say x squared plus 12x plus 36. And I'd be like, yay, kudos to you. And then I'd be like, okay, smarty pants, what about x minus 8 squared? And you would FOIL it out again and you'd say x squared minus 16x plus 64. And I'd be like, oh, you're so awesome. Last one. And then I'd say, what about x minus 11 squared. And again, you would FOIL it out, first sign, outside, inside, last, and you say x squared minus 22x plus 121. And I'd be like, ooh, smarty pants. What do they all have in common? And you'd be like, pair and share at this moment. Let's talk to each other. Oh, I see. Well, if I was to take this last number and multiply it times 2, that gets me my middle number, and square it itself, multiply by itself, it gives me the last number. Is that true? 6 times 2 is 12. 6 squared, 36. Negative 8 times 2 is negative 16. Negative 8 squared is 64. Negative 11 times 2 is 22. Negative 11 squared is positive 124. Ooh, so then I'd be like, okay, smarty pants, try to go backwards. What would you get if you had x squared plus 14x plus 49? And you'd be like, ooh, I know this one. The radical of 49 is 7. So x plus 7, because 7 times 2 is 14. Boom, so it'd be x plus 7 squared. And I'd be like, you're a genius. And I'd be like, last one, x squared minus 20x plus 100. And you'd be like, well, the square root of 100 is 10. And I would see if it worked, and that's a minus. I'm going to make this a minus. So it's a negative 10 times 2 is 20, and negative 10 squared is 100. So booyah. That's what they're doing here. If you look to see, radical 25 is 5. What's 5 times 2? That's 10. Does that work? Yes. So what they did is they rewrote this top part to be this part right here. And then they did what we did before. How do you undo something that's squared? Well, you take the square root. So if I take the square root of both sides, I'm going to get rid of the exponent, and I just have x plus 5 equals plus or minus 7. So I have plus or minus 7. I'm going to get two answers because a quadratic hits the x-axis how many times? Usually twice, which means I usually, not all the time, but usually I'm going to have two roots. So I'd say negative 5 plus 7 is 2, and then negative 5 minus 7 is negative 12. Let's try this again. And I'm sorry, but I'm going to have to go faster so I can make this video shorter. Feel free to pause me at any time. I would say to this problem, radical 36 is 6. 6 times 2 is 12. There's a minus. I'm going to add a minus in here. Equals 25. And then to get rid of the exponents, I'm going to take the square root. So I have x, ooh, that's ugly, x minus 6 equals plus or minus 5. X plus 6, not x plus 6. I'm going to add 6 to both sides. So I have x equals 5 plus 6 is 11, or negative 5 plus 6 is 1. So which means I'm going to cross my x-axis at 1 and at 11, which would be somewhere way over there. Doing this again. Pause me, see if you can do it without me, and then push play. Square root of 64 is 8. 8 times 2 is 16. Yes, this is a perfect trinomial. So x minus 8 squared equals 49. Take the square root of both sides. X minus 8 equals radical 49, which is plus or minus 7. Add 8 to both sides. X equals 15 or positive 1. Again, I'm going to hit my x-axis at 1 or at 15. Now this one is called irrational roots because it's not going to work out as a perfect square on your right hand side or your left hand side, depending on how you set the radical up. But this should still be a perfect trinomial. Otherwise, we're going to have to do what's called completing the square. So if I take half of 9, or not half of 9, take the square root of 9 and make that 3. 3 times 2 is 6. Yes, this works. So what they did is they rewrote that like this. We've already done that before. And then they take the radical of 32. 32 is not a perfect square. but I do know radical 32 is made up of radical 16 and radical 2, and radical 16 is 4, so 4 radical 2. And that's how they got this part right here. They have a decimal. You don't need that decimal. I wouldn't do it. So let's try one together. First, I always check to see if it's a perfect trinomial. If it's not a perfect trinomial, we're going to have to do something completely different. So I would say plus 16, square root of it is 4. 4 times 2 is 8. Yes. So x plus 4 squared equals 20. Take the square root of both sides. X plus 4 equals, square root of 20 is made up of the square root of 4, square root of 5, which is 2 radical 5, plus or minus 2 radical 5. And I forgot my plus or minus. Minus 4 from both sides. These aren't alike. You can't add them together. You can't say negative 2 radical 5. So your answer is negative 4 plus or minus 2 radical 5. Now some people might say, can I write this? Plus or minus 2 radical 5 minus 4. Yeah, you can. But for some reason, the math books and Ms. Braffold really thinks that's more pleasing to the eye. Technically, they're the same thing. All right, we didn't get that far. So if you get done, I went fast. Stop, pause me, rewatch, take your notes, give your notes to Miss Ayler. Well, not give them, but short, and then she's going to give you your assignment. It's very short. The last part on your assignment looks something like you have to tell me what C is. So let's say I had x squared plus 8x plus c. What does c have to be in order to be a perfect trinomial? So you're going to have to go backwards. Half of 8 is 4. 4 squared is 16. So if c was 16, it would be a perfect trinomial. Let's do another one. I just seen that was there. Let's say it was x squared minus 16x plus c. What does c have to equal? Well, negative 16 divided by 2 is negative 8. Negative 8 squared is 64. So if c is 64, then it is a perfect trinomial. That's the last part on your assignment. All right, good luck. I'm going to see you on Friday. Bring me some questions you have.